So you'll recall when we did Theorem 3.13 last week, and this was an example of using the axioms to do a proof. I was a bit naughty and I left out a step, or I did two steps in one really, and I shouldn't have done that. So I'm coming back here just to show you where that step was. So this was the setup we had for all x and y in R. 0 less than y less than x implies y squared is less than x squared. So we started off by saying let x and y be in R, and we assume that 0 is less than y is less than x. So what does that mean? So we can pull that string of inequalities apart. It says 0 is less than y and y is less than x. So that's just the definition of this where we put everything together. And we can also pull out that 0 is less than x, and that's by the order axiom O2 transitivity. So that just says if you've got a string of these inequalities, then you can compare parts of that string without including the thing in the middle. So we've got 0 is less than y is less than x, and 0 is less than x. So now I'm starting off with one of these parts of this statement. So I've got y is less than x, and in the lecture I went straight from y is less than x implies y times y is less than y times x, and I said that was by the order axiom for multiplication, since y is a positive number. That's not strictly true. What is true is that I can say y is less than x implies y times y is less than x times y, because the order axiom says I can multiply through on the right by a number that's positive, not on the left. So that's the step I left out. To get from here to here, then I would just note that x times y is the same as y times x, and that's by axiom M3. So that just means that multiplication commutes. So instead of going from here straight to there, I really did two steps in one. I should have put that step in first. From that point on, this is just y squared. That's how we denote y squared. So I've just pulled those two things together. So that was the end of the first part of the proof, and then everything's the same for the second part. So just to recap, what I'm doing is I'm putting this step in because I'd really done two steps in one in the lecture. You could do two steps in one here if you wanted to, but you would have to note which two steps you used, and I didn't do that in the lecture. So be a bit more careful than I was, and I hope you're enjoying the assignment doing these axiomatic type proofs.